Good morning, students. Today we'll start a new chapter called construction. Now, construction means to build or create a structure. Why do we need to study construction? In this chapter, in mathematics, we'll not be constructing buildings or something like that, but we'll be constructing angles, lines, or shapes like triangles. So, now why do we need to study that? Because in your previous chapters of geometry, that is your previous geometry chapters, including lines and angles, circles, or maybe triangles, you might have revealed a lot of theorems. And you might have noticed you need not to have the exact shape or size of a triangle or exact radius of a circle. And the images are just drawn to help you visualize. They are just an aid for proper reasoning. They help you visualize where and how the angles are there. And the angle also need not to be exact 60 degree if you're proving something including 60 degree. So why do we need to study geometry? Why do we need to study construction in here? It is because in some places, for example, if you're in architecture and you need to draw a house model, you need to know where and how exactly the things are stacked around each other or over each other. You need to know exactly what angle is made of the stairs or maybe the inclined plane. Also, in designing tools, like if you're designing parts of a machine or maybe you're designing something, including a bridge or something like that, then you need to know at exactly what angle is the bridge is, and you need to know how the thing works out of the angle. So hence, we need to know how to construct things, because in such examples, we need to have a real and most accurate intuition, because we have to make them in real life. So they are not just a visual aid, but also a very important tool to help us visualize how things will look up in real life. So hence the construction is very important in few of the fields that you might end up taking after you have completed your schooling. So let us move on to basic geometrical instruments. Now you might be owning, now since you're in class 9, you might be owning or you might have seen a geometry box. Let us break it down that what all things you have in a geometry box. There it must be overwhelming to see so many things, but the only useful thing in this chapter that you might be using are, first is the compass, and the second is a graduated scale. These two are the most important tools in your chapter. But let us see what all things do other things make up. So first thing and the most important thing in a geometry box is the graduated scale, which is very important, and it must look like a long triangle which is having markers. That is, on one side we might be having equally spaced marks, and it is 1 centimeter, which are further divided into millimeters. And on other side, you might be having inches. And the next things that we have are a pair of set squares. These are the triangles that you have, like these. So the first set is of 60 degree and 30 degree, and this is 90 degree. Right? So first triangle is like this, and the second is, this is 90 degree, 45 degree, and 45 degree. So these are your second things that you have in a geometry box. The next thing is the pair of dividers. The dividers is a compass looking like object, which is like this. It might be having two legs. It must be having two legs and needle at both of the ends. So this is our divider. The next thing and the most important thing, as I said earlier to you, is the compass, which is like this. It has two legs, but at one leg there is a holder for a pencil, a hole in here, a pencil space, and on other end it is a needle. And the last thing that we have is a protractor, or as you might be calling it, a D, because it looks like a D and it have angles marked over here. This is a 90 degree, and this might be a 60 degree, this is 45 degree, and 30 degree, like this, all the angles are marked over here. Now, now let us see what a geometrical construction means. A geometrical construction. uh, Now let us see what a geometrical construction means. A geometrical construction is a process of drawing geometrical figures using only two instruments, an ungraduated ruler, also called a straight edge, and a compass. Now, what does this line mean? First of all, let us see what is a geometrical figure. These are the figures that you see in real life that are made up of lines, curves, or um, let us say angles. Yes, these geometrical figures are made up of line, curves, or angles. You might have seen them in real life a lot of times. For example, the book you might be using to learn construction is a cuboid, and cuboid is a geometrical figure. The ball you play with is a sphere, and sphere is a geometrical figure. A sheet of paper is, you can call it as a rectangle. Though it is a cuboid, but the height is too small, so we can call it a rectangle, and a rectangle is a geometrical figure. All these things, triangles, circles, all these are geometrical figures. Now, we have in geometrical construction, we make these figures using an ungraduated ruler. That means we just have a straight rectangle, and that is why it is called a straight edge, because there is no other markings for it like this. It just have a straight edge that help us to draw straight lines on paper, and that it do not have markers. That means that our length is not very important. The measurement that we may have is not important in our geometrical construction. And the second thing that we use is a compass. Compass helps us in drawing angles and arcs. The next thing is in construction, in just construction, where measurements are also required. In some cases, we need measurement. For example, I just gave you the example of architecture, who builds house. We need to know where exactly the things go. So measurement might be important, and scaling the things down is important over there. So in construction, where measurements are required, we may use a graduated scale, that is the scale that have these measurements, and also a protractor, that is a D, like this. You might use these two things to have accurately measured where the things goes and what exactly the angle or the size of the object is. Now let us start our first construction, which is the most basic construction. It is to draw an angle bisector of a given angle. What is a bisector? It is the line that divides the angle into two equal parts. That is, this line, this angle, and this line are equally divided. They are both equal, and this angle is divided into two equal parts. So this is our bisector. Now, how do we construct it? Like here, there are two rays drawn. First is BA and BP, and they're making an angle, as you can see. So first of all, open your compass not too wide enough to make the arc, not too wide, not too small, and draw an arc by keeping your needle at B and just draw an arc like this. Do not open your compass too wide to make it arc over here, or too small to make it over here, because that won't help. That will cause you trouble in constructing it further. And also, it is also a matter of beautification part, though it doesn't make any difference if you're able to do it correctly, but it will cause you trouble because it is too large and it doesn't look nice, and it is too small that you may find difficult to handle the points that are given over here as separate. Now we have made a arc over here, and let us now name these arcs. The point where this arc intersects our BP is called D, and the point where it intersects BA is called our E. Now just put your needle again at BD and draw another arc like this. And now next is to put your needle at E and draw a arc over here. And let us name this point as F. Now we'll just join B and F. This line that we have got is our angle bisector. It is dividing our angle EBD into two equal parts as EBF and F and DBF. So we have got an angle bisector by this kind of construction. Also, it is important to note that we have to open our this compass not too small that it is just making an arc over here, because then if it is too small then the circles won't intersect with each other. That is these are the arcs of the circle, right? So we have made the arcs so wide that they intersect with each other. So just try to open it more than half of ABE. That is, try to open it like this, or maybe you need not to move the size of the compass by and just keep it as BB that was earlier. Now let us see the proof, because I've just said things and we are mathematicians, and we do not just go by things saying that now this is our construct, that this has made angle bisector. We need to see the proof. So let us see the proof. First of all, this is how our angle bisector was constructed, and we have the same diagram over here so that it helps you visualize what things have been done. So first step is to construct or to just join the lines DF. Now we're joining the line DF, and the next thing is to join the line EF. Now we have got two triangles, that is the triangle PEF and the triangle PDF. Now let us examine these two triangles. We can see that PE here is equal to PD. And why is it so? It is because we have drawn this arc having the same radius of the circle. It is the arc of the same circle. This. And radius anywhere on this circle is always the same. Radius is always a constant for a circle. So we have BE equals to BD. The next thing that we can see is BF is a common in these two triangles. BF act as a common. So we can write that BF is equals to BF, which is obvious. And then next is we have put in the next step we have put our angle. We have put our needle over here and drawn our arc, and without changing the radius of the compass, that is without shortening or maybe squeezing or widening it, we have put it over here, keeping the exact size intact uh, of the radius of the compass, and we have drawn an arc over here. And hence, we can see that these two arcs, the radius, are the circles having the same radius, right? These two are different arcs, but still they have the same. They are the parts of circle that have the same radius, and since they are the same, so we can say that EF is equal to DEF. EF equals to DF, D equals to D. Now we have got all three sides as equal to each other. So by side rule, we have proved that DEF is congruent to PDF. Now because of their congruency, we know by congruent parts of congruent triangles that angle EBF would be just equal to angle DBF. And hence we have proved that we have followed the right steps to make up an angle bisector, because it is dividing this angle in equal parts. Now let us move on to our next construction, next basic construction, which is to construct a perpendicular bisector. It is also simple and easy. First of all, just make a line segment AB, and now open your compass wide enough, that is, it should be more than half of this line segment. Let us consider that we are opening it like this, of this width. So we'll consider that our radius of compass is this much. Now put your needle on A and draw an arc over here. Now next, without moving your needle, go to the bottom of this line and draw another arc like this. And now move your needle without changing its radius, without shortening it, widening it. Just keep the compass intact and place the needle at P and then again draw an arc. And similarly, it should intersect and similarly draw an arc on the bottom. And now let us join, let us name the points as P and Q. And now just join the P point and the Q point. Also, you should remember that why we have opened the compass from A as more than half, because if it would have been less than half, then these two arcs would never have intersected, because the circle would have been completed over here and this circle would have been completed over here. So they would never have touched and we would never have intersected. So we would not have got the point. So it is important to open your A right here till here. Now, now this line that we have got is actually our angle. It is actually our perpendicular bisector. Now let us name this point that PQ intersect AB as M, and PM divides the line AB into equal parts. AM equals to MD, and also the angle that AMB makes is 90 degree, and similarly is the angle PNB. Now, since we have done the construction and I have just only said that this is perpendicular direction, this is perpendicular bisector. So let us see how we can prove them. Let us consider its proofs. To prove that PMQ is the perpendicular bisector of line AM, let us first join AP, PB, PBQ, and QA. This is sort of a parallelogram that we have get a quadrilateral. Now let us consider these two triangles, PAQ and triangle PBQ. Now we are considering these two triangles. In these two triangles, AP would be equals to BQ, and this is because we have not changed the radius of compass, and we have put it over here and drawn an arc, and this arc, these arcs are of same radius, and the circles that make up these arcs are also of same radius, and hence we can say that these two are actually the radius of circles that have same radius. So AP and BP are equal. AP would be equal to BP. Now similarly, AQ and BQ are equal because we have not changed the radius. I just moved it over here and done the same thing as we have done in P point as in the Q, and that is why it is important to keep the radius of the compass as equal whenever you move to point A and to point B to draw the intersection, because otherwise these two sides would not come out to be equal. The next point is that that we can see in these two triangles is PQ is the common. So we have just proved that AP is equals to BP, AQ equals to BQ, and PQ is common. So all three sides are coming to be equal. So by SSS rule, that is side rule, PAQ is equal to PBQ, and by CPCT, that is congruent products of congruent triangle, we can say that APM, that is this angle, would be just equal to the angle BPM. But this have not proved that our AM would be equal to BP, or that is AM would be equal to PM, or this is 90 degree. But so hence we'll use the result of this first step, that is proving these two triangles equals, this result in our next step to prove the triangles APM and PMP as equal or congruent, so that we can get AM equals to PM. So let us move on and see how we'll do that. And now we're considering the triangle PMA and PMB. In these triangles, AP is equals to BP. We have already known, so this is equal. Then PM is a common part, so this would obviously be equal. And we know that this angle and this angle are equal, as we have just proved in the previous step of proving PAQ and PBQ as congruent triangles. So we just know that APM and BPM are equal. So by SAS congruent rule, we have just proved our triangles PMA and PMB as congruent. And hence, what follows is the theorem CPCD, congruent parts of congruent triangle, that proves that AM is equal to MB. AM equals to MB. Also, to prove that it is 90 degrees, we also know that by CPCT we can have our PMA, that is this triangle PMA, this angle PMA, to be equal to PMB. But it is not saying that it is for making 90 degrees. And to prove that it is making 90 degrees, though they are equal, we'll have to follow a new, we'll have to know a new theorem, that is a line that makes a 180 degree. We always know that this angle is 180 degree, and these are making this supplementary pairs. So we'll just add them up, that is PMA plus angle PMB should make 180 degree. And we know that these two are equal, so I can just write 2 PMA to be equal to 180 degree, and we cut 2 from here, it is 90 degree. So PMA is coming out to be 90 degree, and we already know that PMA is equals to PMB. And that is how we have just proved that this is 90 degree, and hence PM is perpendicular, as perpendicular means 90 degree, and it is a bisector because these two sides are coming to be equal. Now let us move on to our next basic construction, that is to construct an angle of 60 degree at initial point of given ray. Our ray is A to B. So first, so the question that we have to do is that we have to have a ray, and it is having an initial point A, and we have to construct an angle such that CAB would be equal to 60 degrees. Suppose we have to make a 60 degree angle at A. So to do that, first of all, take your compass and open it at a radius that you like, that or which is not too wide or not too small. So let us open our compass and draw an arc, keeping A as center. I will just draw over here. So this is an arc of a circle, right? Now, keeping the same radius, first of all, the place where the arc intersects with A and B, we'll mark it as point D. And then keeping D as our center, place the needle at D and then mark another arc. Do not change the radius of the compass. Marking another arc, we have this point that where the new arc and the previous arc intersect as E. And now we'll join AE. Now we'll join AE and let us mark this point as C, and is given as that we have to construct a ray AC. So we'll construct the ray AC. And now this angle CAB, the angle given by the intersection of these two arcs, is equal to 60 degrees. And this is the construction of 60 degree. And now let us prove why this angle is 60 degrees. So now to prove that, first of all, we join our D to E. Joining our D to E, let us see the sides of this triangle. As we have got a triangle ADE. Now we know that AE would be equal to AD. And why is it so? It is because this arc that we have made is actually the arc of a single circle. And when we construct a circle over here, the radius, this and this, that is AE and AB would be the radius of the circle, which will always be equal. Hence, A equals to AD. And similarly, we have also constructed this arc keeping the same radius of the compass, and hence the circle that this arc is a part of would also have the same radius as as circle of this arc, and hence ED, hence our ED would also be equal to AE, or which is equal to AD. Since all the sides are equal, we know this kind of triangle is an equilateral triangle. Equilateral triangle, the triangle having all the sides as equal. And we know that the property that follows an equilateral triangle along with the sides is that all its angles are measured to be 60 degrees. And hence we have just proved that this angle is 60 degrees, this angle is 60 degrees, this angle is 60 degrees. And our main motto and the much needed angle is this angle, which is just 60 degrees. Hence, now we have learned how to construct a 60-degree angle.